Okay, so very, very briefly, I'm just going to talk about bolt preload. So bolts loosen due to cyclic loading, vibration, and other effects that cause tension to be lost in these bolts with time. So I'll give you an example. There was a cart that I made with a student team when I was in undergrad, and we had wheels on this cart, and we had bolts to hold the wheels on the cart, and we just needed this to work enough to show it off to our business class, which this was just a product prototype. So we had this wheel on here, but after we would I guess it's something like this, okay? So after we would spin the wheels for a few, let's say, 30 meters or so, the bolt would have come loose and the wheel would fall off. And that could happen for a number of reasons, but essentially what's happening is there's cyclic loading, there's vibration, but the biggest problem is that the bolt is not secure. It's loosening with time, and it's unscrewing itself as it undergoes this cyclic loading. And we were taking this upstairs and downstairs and everything and doing all kinds of testing with it, and it continued to have this problem. Well, what we should have done was maybe looked and said, okay, well, can we preload this bolt? Or is there another way to design this better? Now, we didn't do that because it was a business class and we were doing fine, but this is an engineering video, so we'll talk about it. Alright, so bolts with a 60% proof load for the preload are less likely to loosen. Now this, I think, is just for general use. And alternatively, you can also use fastener braking schemes. You could, for example, use some kind of a adhesive braking type of material to secure that nut onto the bolt. There's other methods, so those are things that you can look up more on if you're doing a project with this. So here are a few of the steps of how to create preload in a bolt. So first, you're going to want to solve for the fatigue factor of safety. So you will want to know, for example, what we're trying to solve this problem for, like what is our goal. And then we are going to check for yielding, so we use the proof strength to check for this. And if you're using the Shigley machine design book, then look at tables 8.9 to 8.10, and you'll see the values for various materials. And there's a recommendation also in their book to use 0.85 of the yield strength for materials that aren't given in the tables. So here you would take that proof strength multiplied by the area, and then you'll find the proof force, and here you plug that in here then, and you'll see what that value is for non-permanent connections or reused fasteners. So if you're going to reuse a bolt, you would want to go with this 0.75 value. And then if this is a permanent connection, then we'll use a 0.9 value. And so with this wheel problem that I've proposed, I would probably want this to be a wheel that stays on permanently. So I might go with this 0.9 value. But if this is maybe a testing rig where this is the bolt that we're going to be taking on and off to secure something in the test rig, maybe the 0.75 value makes more sense, so we aren't replacing bolt each time. But if this is a very precise testing device, then we may need to replace that bolt every time to get more precise results for our testing. Okay, so hopefully that makes sense.